So I'm back again with the second experiment, that is half adder. Again, we'll be using OrCAD Capture Light Edition. We will be starting with we'll go to File, New, and we will open a new project, and we will name it like I'm making adders, so I would name it as adder, or you can give any other name which you want. I'm just putting adder so that I can remember it later. Then I will press OK and go to hierarchical block, and we can open this plus sign of adder file, and then we can open the schematic one, which would be the hierarchical block, page one, and here it goes. We got the hierarchical block. First of all, let's remove this. As discussed in the first experiment, we will remove this, and because this may create problems, so it's better to remove it first and then start doing the experiment. Now here the problem is a little different because we have to make half adder, so we need two inputs and one output. In half adder, we have two inputs and one output. Sorry, two outputs. We have to add one more output over here. So I will press this hierarchical block, this particular block in the middle, so the color will change and it will be highlighted. I will go to H. You can see there is this place pin H, and when I press this, I will get this option of giving some name to the output. So I will be putting if it's an adder, I can put here carry, because out will be sum, so I can put carry, and here I will place anywhere of my choice carry. Then we will be using end mode, of course, because otherwise it will keep highlighting. Then we have to go to wire, place wire. It's on this side, and then put a wire over here because we need to put voltage marker later. So we need a wire and more end wire. Right click and my see, even if we right click and press end wire, we won't be able to end it. So again, I will have to do it. So don't worry if you have to do it two times. There's no problem. Uh, for inputs, we have to again go to place parts, and we have to press source, and we have to press digital block, and then OK, and we have to place both the inputs here like this. Okay, and then finally end mode. Once we have done this, again we need to go to wire and place the wire and connect it properly. I told you, once we connect it, uh, wherever we want to end, we have to press it once, otherwise the connection will not be made. So again, I will have to do this like this. Okay, so end wire. So here you can see this wire has gone a little up, so you can put the backspace to this and remove this portion. And here there's a red mark which will not be good actually. So now it's fine. So you will have to take care of all these things. Once this is done, again we will try to change the input, because I told you off time. Generally, if we change any one of them, it's not like I'm more comfortable with changing off time. You can change on time also. 0.3 microseconds and okay. Once it's done, you can go back by minimizing it. You go back to schematic 2 and page 1, and then you can place maximize it, of course, and then you have to place parts, because you need eval. You will have to, for place parts, you will have to press eval. Now you have to make a half adder. So for making a half adder, you need one AND gate and one XOR gate. So first of all, XOR gate is 7486. So I'll write it and press OK and place it somewhere like this, because I need both the inputs to this. There's a problem. I will place it here because I have to, first of all, I have to take this output little far away, otherwise it will be a problem, and I will have to remove this wire. Then I can place this here like this, so it makes my thing a little easier. Once this is done, I have to go to place part again, and I have to select here 7408, which is an AND gate, which I need, and OK, and place it somewhere here, because obviously you need carry to be generated. So see, we have only one out as the original hierarchical diagram, which has in one, into, out. Now I need carry also. So for that, again, I will have to press this P, place port. Place port gives me an option that I can add any number of outputs or inputs. For example, I need carry, so I will press carry, write carry, and see I will have to select one of them. And it's very important to select it properly, because here you can see it is the output portion. Here you will be connecting with the wire. So port L will be selected and OK will be done. And like here, if I place it somewhere here, it will be fine, I think. Done. So I named it as carry, but it has not come, so I will have to rename it here. I will be putting like this, double click, and I will put carry here. That would be fine. And I have named it as carry as it is in hierarchical clock. So my major work is done. Now I have to go to wire again and do the connectivity. So while connecting, I will have to make sure that the connection is proper. So right. See, connectivity is very, very important. I'm just putting stress on that because I'm not getting any errors because I'm making connections properly. If you're not able to make the connections properly, of course, you will have errors and then you will find it very difficult to do. So, while doing the connections, just make sure that the connectivity is there and it is proper. And it should not be more than required. Like in this case, you can see I have pressed more. So, I will be doing it later. Not later, I will do it now only because it may create a problem later. So I'll have to remove not this. See, this is fine, but this is okay. It's fine, I think. No problem, I think there's a problem. So I can move it. No, move with this. Again, go to wire and connect these two. Now, in half adder, what is done is this first any one of these inputs goes towards like this. It goes to the first input of, see, the connection is not proper here, so the problem will arise. So I will have to do the connections properly. There is a wire which is coming like this. So done, and finally it's done. Okay, so here this one is first and the second one you will have to do it, there's no option actually, so I will have to move like this. Don't press in between, otherwise it will actually not connect properly. There should be no connection in between. Once this is done, end wire. Now you are okay with it. Now the circuit is complete. You see, there is an XOR gate 7486 and there is an AND gate 7408. You have done the circuit. Out and carry and in one into are similar to the hierarchical block. I can minimize this. My circuit is ready. I can go back to the hierarchical part, and here no. This is 748. This I don't need. I will have to go to page one. Adder. I will have to go to adder one. So adder में page one जो है, it shows like this. Two inputs which I had made earlier. So now here, mm, you will have to uh, select this voltage marker and place it here at the inputs and the outputs. And make sure you are placing it on the wires only. Otherwise, again, if you don't place it on the wire properly and touch it with any of the block portion or any of the digital block, it will create problems and there will be errors and you won't be able to get the output. Once this is done, go to PSpice, new simulation profile. You can put it as adder one because you have named that adder. So I would suggest keep it a different name. Otherwise, it may create confusion in the software. Highlights at the bottom, then you can change it to microseconds, 10 microseconds as I'm doing. For micro you can use U, press OK. You have to change only run to time. Rest others you are not supposed to change. Okay, once this is done you can sorry, I had put these voltage markers earlier. So when I do simulation, new simulation profile, it deletes those voltage markers. So it's better to place it after like new simulation profile. So I'm doing it for again because I did it earlier. So once this is done, you can press run. You're getting the output, and the output is coming, I think, very very proper, because for 00 it is giving me 00, for 10 it is giving me 10, first two are inputs, and this is sum and this is carry. So for 1 1 you are getting output as 0 and some carry as 1, so it's working fine. You have to read the output based on the truth table. I'm not giving the truth table, but you can write a truth table on your copy at the side and keep it on one side, and just verify of the truth table with this output which you are getting. So I have tried to find out like 2 3 inputs, and I got the output right. So the circuit is working fine. So this is how it works. So if you have any queries regarding this, if you have doubts or you're getting some errors, please don't forget to write comments and ask questions. I would love to answer them in this comment section, and please don't forget to subscribe. Thank you so much.